So now look into this difference between this resistor and capacitor, how they behave. So suppose if I apply 10 volts across the resistor, the complete 10 volts at an instant time, it will get applied across the resistor. That means the voltage drop across the resistor will be 10 volts as soon as I switch on this voltage. Okay? But here, if I apply voltage across the capacitor, you can observe that slowly it just gets charged. Charges across the conducting plates keeps on increasing slowly, and capacitor gets charged very slowly, and then you can see the maximum voltage at particular time interval. That depends upon, that we'll study how it depends based on an charging of a capacitor, depends upon the material and resistance, what you applied in the circuit, all those things comes into picture. So this is how capacitor and resistor will behave. So therefore, as I said, depending upon what dielectric you are used, based on that, we can find out what is the capacitance of a capacitor, which is equal to epsilon A by D. What is the unit of capacitance? Farads. Okay, so this is capacitor. The device or the component name is capacitance. Okay, so what is the capacity of storing that electrostatic charges? That is called as capacitance, and unit of capacitance is farads. How does it depend? What is the capacitance of a capacitor? Depends upon what is the area of cross section of the conducting plates, what is the dielectric material, the distance between the two conducting plates, or the thickness of the conducting plates. As the distance between the conducting plates keeps on increasing, capacitance keeps on decreasing. As the distance decreases between the two conducting plates, capacitance keeps on increasing. So therefore, you can observe in ceramic capacitor. So we have different types of capacitors. I'll just go through that. Depending, this ceramic capacitor you can just observe. You can open afterwards. This one, scratch it off and see. There will be an ceramic disc will be there. Centrally, ceramic disc iruttaste. That acts as a dielectric. On either side of that, they coat with the conducting material of same thickness. You can open and see afterwards. Male scratch madadra ee protecting layer, you can see that ceramic disc irutte. On either side of the disc, they are coated with an conducting material. Now it acts like a capacitor. Two conducting plates separated by a ceramic. So on either side, they just connected to conducting material. Gain madidru two leads hakadra either side. This acts like a capacitor. See, such a simple construction, passive component, but it behaves so great, right? It acts like a battery, you charge madbodu, right? So it just stores the electrostatic charges. A very simple construction. Now you can just see that what is the dielectric material. Thickness dielectric material. You can measure and see with an instrument, and you can find out what is the actual capacitance. Measure ಮಾಡಿ ನೋಡಿ ಆಮೇಲೆ. It should be approximately same ಇರಬೇಕು. Got it now? So now let us go to different types of capacitors. See the different types of capacitors. We are studying about, or we are just discussing about the capacitors, right? What are the different types of capacitor? So this is a fixed capacitor. In this again, as I said, depending upon what is the material used for dielectric, we have ceramic capacitor, paper capacitor, two conducting sheets separated by a thin paper rolled, they act like a capacitor. Okay, so this just act like a capacitor. That is paper capacitor. We have an plastic capacitor where ceramic is, inside of ceramic they use a plastic material as a dielectric. And electrolytic we have seen where it different construction. two electrolytes are used there. Okay. So in a particular thing that we'll study how actually there you will get an polarity also in the capacitors. That is electrolytic capacitor. So like that we have so tantalum capacitor where tantalum is used as an dielectric there. So like that we have so many different types of capacitors. Those are all fixed type. Andre the value is fixed. And another one is variable capacitors. So how do you represent? Same capacitor with an arrow like this. In between it represents a variable capacitor. This is a symbol for a variable. Which are the variable capacitor? Trimmer capacitor, gang capacitors. Yeah. Gang capacitor, there are so many plates. Trimmer capacitor, only two plates will be there, imagine. So screw tight marta hodre, distance between the two conducting plates will differ. In gang capacitor, we'll have so many plates. When I just tune the screw, the distance between each plate, first to second, second to third, like that, it varies. Each one set of plates acts like an conducting plates of the capacitor. Okay. So that is an variable capacitors we get in trimmer capacitor and also gang capacitors. And coming to the other one, polarized capacitor, that is nothing but an electrolytic capacitor where it will have an polarity. Positive terminal, negative terminal we can represent for an electrolytic capacitor. Okay. So these are all the different type. So I'll just give it that also, you can just observe. So other capacitors, these are all ceramic and all we have with a different values. We'll go through how to measure the value of a capacitor. And coming to this electrolytic capacitor, how do you find out which is positive and which is negative?
This terminal is power cut.
No, that's not the way. Terminal cut ಮಾಡ್ತೀನಿ ನಾನೀಗ. What you'll do? ಸಮ ಕಟ್ ಮಾಡಿ ಕೊಡ್ತೀನಿ, ಏನು ಮಾಡ್ತೀರಾ? Huh? Can you see the arrow one side? Just check it. Everyone check it. Can you see the arrow? Opposite side?
No.
Correct. One side matra arrow ide. Right? Whichever side the arrow is there, that is a negative terminal always. See? Can you see this? So whichever side the arrow is there, that is negative terminal. Whichever side the plane is there, that is an positive terminal. So you should never look into the size of the terminal. Always this is the way how you just look into the capacitor value or the terminals by looking into the arrow. We'll go to an how to measure or how to represent the value. We'll go next slide. So one by one we'll go through now. And we'll see that each component, how we just come to know. Suppose if it is a resistor, how to find out what is the value of a resistor. What does it represent? Looking into the resistor, how do you just know that what is the value of a resistor? Looking into the capacitor, how you have to know that what is the value of a capacitor. Okay. So these things we'll study next. So these are all the basic components what we have just gone through. And coming to the sources. Morning we discussed about these sources. Which are the different types of sources? DC source, AC source. Okay. What is the difference? This is the DC source where we represent symbol. You just go through first. We can see that DC source is always represented with an polarity. Correct? Positive terminal and negative terminal. The direction of current is always in one direction there. So we represent with a polarity, positive and negative. Correct? So normally we say that the current flows always from a lower potential to higher. Higher potential to lower potential. Current always flows from a positive to negative. Higher potential to lower potential. Okay. That's why whenever the current is considered through the resistor based on this, source, we say that the current where it enters the resistor is considered as an higher potential, positive, and where it leaves the resistor, that terminal is considered as a negative, lower potential. So according to this, how does the current flow in this source, DC source? Positive to negative. So that means from here to here. Correct? That is how we consider. So current always flows from higher to lower potential. That's what we say, right? That is an conventional direction of current flow. Correct? And current source. If you have a current source, how do you represent? This is a symbol for a current source. We always represent, if it is an DC current, again we show with a polarity, positive to negative. We show the polarity as an positive to negative. Correct? So this is how we just show. And this is a symbol for an AC, alternating current source or alternating voltage source. This is an AC source. This is a symbol for an battery. It is a cell actually, not a battery. There is a difference between cell and battery. What is the difference?
Battery things we can use for that.
Cell, number of cells connected in a pattern forms a battery. Cell is a single unit. Okay? So therefore you can just observe. The polarity has been mentioned. So therefore it is a battery cell, we call it as. This is a cell and cells are connected in this way. It will act as a battery. You just see it is connected in series here, right? Okay. So 10 volts, 10 volts, 2 batteries. If I connect in series, what is the total voltage? 20. Got it? Okay. This is battery. Cells connected in series or parallel, whichever way, that depends. What is the amount of current we require? What is the amount of voltage we require? Totally. Depending upon that, we connect or we arrange the batteries and connect with each other in parallel and also series, both the combinations. This is a controlled voltage source. This is a symbol for an controlled voltage source. So output we can just get an controlled output voltage. This is a symbol for variable DC voltage. See, these are all for an fixed. This is also represented for an DC, but it is a fixed voltage. This is for an variable DC source. But here polarity need to be mentioned. This is positive and this is negative. Okay. So wider line positive, smaller line it is negative always. And this is for controlled current source. Shows the direction and also it is the controlled output where we can measure it. Symbols nodekolli first. These are all the meter symbols. Whatever we have seen is an sources. What is the difference? Source supplies an energy. Okay. Required for the operation of the circuit. Isn't it? Meters measures different parameters in a circuit. Correct? So for you, we use it for measurement, that's all. See, voltmeter, if it is with the polarity, DC. If it is with an sinusoidal symbol, AC. So these two, what does it represent? Voltmeter, ammeter, ohm meter, watt meter. So this is a symbol for an operational amplifier. So we know that it consists of an inverting terminal, non-inverting terminal and also output. This is symbol used for an op amp. Transistor symbol. Now we will go work on transistor. How many terminals it has got? 3 terminals. Which are those? Emitter base collector. Okay, and how many junctions will it have? PN junctions? Two junctions. P to N one junction, sorry, emitter to base one junction, base to collector or collector to base, it is another junction. Correct? Two junction, three terminal semiconductor device, which consists of three terminals, emitter, base and collector. Got it? So whenever you just see, that picture has to come to your mind. I'll show the working while we are just going through rectifiers and also transistor operation. I'll show in detail what is the construction, the PN junction construction. I'll show how actually it behaves. Now only we are going through the symbols and all. And what is this arrow represents in the transistor? Yes? There are so many types of transistors you can just go through. Can you just see this? Two different types of transistors. How many of you have seen? Is it SL100? SL, SK na ಯಾವ್ದಾದ್ರು ಇದೆಯಾ ಇದರಲ್ಲಿ? Yeah, you can tell if it is wrong also, no problem. Huh? SL ಇದೆಯಾ ಇದರಲ್ಲಿ? SL100 ಅಥವಾ SK100 ಇದೆಯಾ? This one. Others? ವರ್ಕ್ ಮಾಡಿದಿರಲ್ವಾ SL100 SK100? ವರ್ಕ್ ಮಾಡಿದಿರಾ? ಸುಮಾರು ಸಲ ಮಾಡಿದಿರಾ? ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಮಾಡಿದಿರಾ? ಆಂಪ್ಲಿಫೈಯರ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸು, ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಆಸ್ ಅ ಸ್ವಿಚ್ ಮಾಡಿದಿರಾ? ಮಾಡಿದಿರಲ್ವಾ? ವಾಟ್ ಇಸ್ ದ ಸೈಜ್? ಹ್ಯಾವ್ ಯು ಅಬ್ಸರ್ವ್ ದ ಸೈಜ್ ಆಫ್ SL100 SK100? ಇಷ್ಟೇ ಇರುತ್ತಾ? So this is what we call it as a metal cap transistor, plastic package transistor. ಇದು ಮೆಟಲ್ ಕ್ಯಾಪ್ ಇರುತ್ತೆ, ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್. ಟರ್ಮಿನಲ್ಸ್ ಅಷ್ಟೇ, 3 ಟರ್ಮಿನಲ್ಸ್ ಓನ್ಲಿ. ಎಮಿಟರ್ ಬೇಸ್ಡ್, ಬಟ್ ಟರ್ಮಿನಲ್ಸ್ ಶೇಪ್ ಇಸ್ ಡಿಫ್ರೆಂಟ್, ಅಲೈನ್ಮೆಂಟ್ ಇಸ್ ಡಿಫ್ರೆಂಟ್. ಇದು ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಅಲ್ಲಿ ಇದೆ, ಯು ಕ್ಯಾನ್ ಸಿ ಇನ್ ದ ಪ್ಲಾಸ್ಟಿಕ್ ಮೋಲ್ಡೆಡ್. ಮೆಟಲ್ ಕ್ಯಾಪ್ ಅಲ್ಲಿ it will be always in an V shape. I'll give it everything, I'll give it for you to checking also. I'll tell you how to test the transistor, how to check the polarity, everything I'll tell. I'll just give it to you, I'll explain and you are going to check it. Okay? Only now identify it, that's all. Got it alva? This is a metal cap, this is the plastic package. And now, what does the arrow represent? Ivella ondena. What does the arrow represents here in the symbol?
Forward drive.
Arrow. It represents the current direction. Correct? And NPN nalli current direction is always out of your emitter terminal. I'll show the construction and I'll explain. You remember this. Whenever the direction of arrow in a transistor symbol is out of the emitter terminal, it is an NPN transistor. NPN because current flows away from the emitter terminal. Okay. In PNP terminal, current flows into the emitter terminal. Got it? So that means, yeah. Okay. emitter, base, collector. Okay. We know that emitter base should be always forward bias to make the transistor to conduct. Suppose if it is an NPN, let me say. Materials used here is emitter is N type, base is P type, collector is N type semiconductor. In that case, if I wanted to make it conduct, emitter base should be forward biased, collector base should be reverse biased. What do you mean by that? Forward bias andrena emitter P type of semiconductor should be connected to positive terminal of the battery, and N type of semiconductor should be connected to negative terminal, or otherwise I can say that P type will have an higher positive potential compared to N type. So then we call that as an forward biased. So now here what happens? Emitter base should be forward biased. Correct? So what should I do? Negative and positive. And collector base should be reverse biased. So what should I do here? Reverse biased. Negative. Illi positive. So this voltage is called VCC. This voltage is called VBB ಅಥವಾ VEB. ಯಾವ್ದಾದ್ರು ಹೇಳ್ಕೊಳ್ಳಿ. VE, let me say. I'll say VBB because positive terminal ಯಾವುದು connect ಆಗಿದೆ ಅದನ್ನ we represent, right? So if this is the case, how does the electrons move? Majority carriers of this N type is electrons. ಹೌದಾ? So emitter, it will just emits the electron. This is the directions to flow. Collector collects and it is pulled by this positive terminal, and very less leakage current will flow here. Correct? I'll explain in detail. Just direction torsake. I just wanted to show you the direction of polarity. So look into this. If this is the direction of flow of electrons idre, what will be the direction of current? Conventional direction of current. Always opposite to the flow of electrons. Correct? So now these electrons will flow in this pattern. ಹೀಗೆ ಮೂವ್ ಆಗುತ್ತೆ. Okay? ಹಿಂಗೆ. So what should be the direction of current now? Opposite to this. ಅಂದ್ರೆ emitter ಇಂದ away. This is IE. Collector ಅಲ್ಲಿ what happens to the collector? Collector ಗೆ direction of current. ಇದಕ್ಕೆ towards. Correct? This is IC and this is IB. Correct? Junction hatra nodi. What is the junction hatra current ena? Apply the KCL here. Kirchhoff current law. So now look into this. IC is away under this direction. Junction hatra IC will be like this. At the junction, what is the IE is this way. What is IC? Into, correct? This is your IC. Hing tane move agtide. So now at this junction, I can see that IE is towards, IC is away, IB is away. Correct? Sari idya? Is there any doubt? How the charges are moving? Majority carriers in the emitter are electrons, that moves through this and it will be collected in the collector, and this charges will flow like this and leakage current will move like this. This is a base charges. Okay. So base charges is away. This is charges. Okay. Collector charges are towards. Emitter charges are away. Correct? This is the direction of charges. Current direction ಏನಾಗುತ್ತೆ? Just opposite to the flow of electrons. Andre, this is IC. Sorry. This is IE. This is IC. And this is IB. Got it? Is it clear? Yes or no? Okay. Now at the junction, Kirchhoff current law apply madadre. What is IE, IC, IB relation equals to? IE is equal to IC plus IB. Why? IB is towards the junction. IB ಕೆಳಗೆ ಬಂದಿದೆ. Okay. Sorry. IB is down. Wait. Look into this. The charges are towards. Current direction is away. Yavadu? IE. Correcta? IC. Yeah. Look into this. The charges are moving into an IC. Okay? Current direction is away. Correcta? Here. What is this terminal? So what is this one? It is collector. This is emitter. And collector ali charges are away. Correct? What is the current direction? Current direction towards. And here charges are away from base, junction. Or I can say away from the base and towards the junction. So I can just say that current is towards the base. So therefore what happens here? IE is equal to IB plus IC. Correct? So therefore IE is equal to IB plus IC. So we know that we consider the current towards the junction as negative and current away from the junction as positive. Towards the junction, if you take any way, you can just take. Away is a negative and towards positive. Take it. And coming to this, I just wanted to know what is the direction of current here into the emitter. Away idya, towards idya. Emitter ge, this is an NPN transistor, right? Is it away or towards?
It's moving towards.
Current is away. That's why the terminals, when we write it, emitter, base, collector. So the current direction is away in an NPN transistor. This is what we call it as an NPN transistor. Did you understand this? Similarly, go for an PNP transistor. How does it look like? P-type semiconductor, N-type and collector. This is PNP. So this is This is Eesh. So which is this terminal? Which one is this? Huh? Which is this one? Emitter, base, collector. This is emitter. Okay. Now, since it is P type of semiconductor, which are the majority carriers? Holes. So here we have an electrons as a majority carriers. Hoda? And here again holes. How does the holes conduct? Did the holes move? Move agatta holes? No. How does it conduct? The free electrons jumps from one hole to the other hole and the conduction takes place. Holes will never move. Whichever the free electrons are there, that jumps from one hole to the other. Suppose for example, itra idre holes, one free electron idre, it jumps here. Okay? And next free electron jump agatte. So this is the movement of electrons. Now the movement of electrons is like this. And when it jumps from here to here, this becomes vacant. Okay? And again when it jumps from here to here, this becomes vacant. That means it becomes a positive hole only. Moment is opposite, but hole moment is generated in an opposite direction to the electron moment. So therefore what happens here? The electron moment is in this direction. Okay? And it flows like this. So again polarity, tell me, P type, N type, emitter base should be forward biased, correct? Collector base should be reverse biased. This is the polarity of external voltage what we need to apply for conduction. So movement of electrons are like this, whole movement is in the opposite direction. This is the direction of, and what is the current direction? IE into, correct? IE is into. These are all charge carriers which are moving. Holes moving in the forward direction, electrons will be in the opposite direction. Holes will never move. The charge carriers moves from one hole to another, making it vacant. So we just see that the holes will get empty in the opposite direction. Okay. So now, if this is the case, the current, electron current will be away. Emitter current will be away. And coming to the collector, the charges moves like this. Therefore, yeah, from here to here it moves. So therefore, we can observe that the current direction is away. I see. Similarly, here also to the base also we can observe that the electrons moves inside. So the direction of electrons will be like this again. Okay. So the electrons moves away. Here also like this. Therefore, base current is away. So we can observe that here in this case, the emitter current, base current and collector current are towards the junction. Emitter current is away from the junction, or otherwise I can say that emitter current is into the emitter terminal. Emitter current is into the emitter terminal. So therefore the symbol is like this. So this is base, collector, emitter, and this is P, N, P. This is the symbol, how we show. So you have to remember that in case of NPN transistor, emitter current is away. the arrow always shows the direction of current flow into the emitter terminal. Therefore, in NPN terminal, always we show that collector current is away. In PNP transistor, emitter current is into the emitter. So, therefore, we show the direction of current as into the emitter. Is it clear? So, to make you to understand that, I just done all these things. So, you can just see the transistor terminal symbol. NPN, emitter current is away. PNP, emitter current is towards. This is very important symbol where you have to learn. Okay. Next. This is nothing but an junction field effect transistor, JFET. We show the arrow. Drain and source is a single channel. Gate will be shown with an arrow based on whether it is an N type of JFET. In N type of JFET, arrow is inside. In P type of JFET, arrow is away from the gate. This you have to remember. NMOS, this is a symbol. PMOS, you can again see there. NMOS, at the source, we have taken the current direction away. In case of PMOS, the current is shown as an into the source. What is D? Drain. G is gate. S is source. Okay. All these things you are going to study slowly. Only this is a symbol recognition of a component. That's all. So third semester you have analog circuit design. You are going to study in detail MOSFET. There. Now you need to study in detail diode and transistor. I'll just explain about that when we come to that exercises. PMOS, NMOS, buzzer, this is the symbol. Okay, I'll share this with you. But you just know everything, you just go through symbols anta kodi barutte Google alli. Just prepare and come. What is the symbol for NPN, PNP, all symbols. You have to learn and come from our tomorrow's class. This is for bell. Electric bell. We just show it with an curve with an flat and with two terminals. Fuse. Look into this. Fuse, we have two terminals. In between it has been connected with an wire. This symbol represents, see here, it is a group of wires taken into consideration as a connector, which we call it as a bus. For example, address lines, say about 8 lines are there. A0, A1, A2, A3, A4 up to A7, 8 lines, it is a group. When we address this, all these will go into address to the memory location. So that we represent it as a bus. If it is bidirectional, we are just showing the arrow on both the sides. Okay, bidirectional means address to data, data to address. We can just show memory location to CPU, CPU to memory location. This is the load. Almost all of you must have seen the fuse. Nodidralva? How many of you not seen? Have you seen the fuse? Can you just make out the wire inside? Check it. Kodtini nimge. Pass it on. So see one kodappa. You collect it afterwards. You can see two terminals where the inside there is a wire connection. And again, rating of the fuse. Check it on the fuse. It has mentioned with an current rating. I just explained in the morning itself. What is the amount or the capacity of current bearing of that wire? Once again, the wire will have some resistance. Correct? The wire which has been connected inside the fuse, one terminal to other, will have an resistance. How do you calculate the resistance? Once again, rho L by A. Area of cross section, length of the wire, what is the material used? Based on that, you can calculate the resistance. We have a resistance. We know what is the voltage applied, what is the current flowing. If the current is more because of short circuit or whatever it may be, the wattage or the power dissipation across the resistor will become very high. Since that can bear only a particular wattage rating, heat jasti agatte, what happens to the wire? It will burn. That's how you say that fused out. Got it? So again, it depends upon the wattage of power that is dissipated across the fuse. Current bearing capacity adike fuse ge they will give it with an current. Look into this one, ratings. Current rating kodirtar 10 amps fuse, 1 amp fuse, 20 amp fuse anta. So it depends upon what is the amount of current it has to withstand. Based on that only the thickness of the wire depends. Have you seen the main fuse in your houses?
Yes.
Manelal fuse nodidra KEB. How does it look like? Ceramic U shape irutte. Howda? This is the one. Okay. So ನೀವು ಡಿಫ್ರೆಂಟ್ ಫ್ಯೂಸಸ್ ನೋಡಿದಾಗ ಇಲ್ಲಿ ವೈರ್ ಏನಿರುತ್ತಲ್ಲ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿರೋದು ಥಿಕ್ನೆಸ್ ವಿಲ್ ಬಿ ಡಯಾಮೀಟರ್ ವಿಲ್ ಬಿ ಹೈ ಬಿಕಾಸ್ ದೇರ್ ವಿ ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ 230 volts ಆಫ್ ಎ ಸಿ ಕರೆಂಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡೊಮೆಸ್ಟಿಕ್ಗೆ 5 amps ಅಂತ ಇಟ್ಕೊಳ್ಳಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬೇರ್ ದ ಟೋಟಲ್ ದಟ್ ಮಚ್ 230 into 5 amperes. So for that, what should be the wattage rating of that wire? Based on that, they will just connect. What should be the resistance? Resistance again, what is the wattage capacity? How much it can bear? So as to heat generate, we know that the power dissipated in the form of an heat across the any resistor. So this is also just acts like a resistor. Heat ಎಷ್ಟು ಜನರೇಟ್ ಆಗುತ್ತೆ, ಎಷ್ಟು ಡಿಸಿಪೇಟ್ ಆಗುತ್ತೆ, ಎಷ್ಟು ಟೆಂಪ್ರೇಚರ್ ಅದು ವಿಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಆ ವೈರು. ಅಷ್ಟು ವಿಸ್ಟ್ಯಾಂಡ್ ಆಗೋಕ್ಕೆ 230 volts 5 amps-ಗೆ ವಾಟ್ ಶುಡ್ ಬಿ ದ ಡಯಾಮೀಟರ್ ಆಫ್ ದ ವೈರ್ ದಟ್ ದೇ ವಿಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್. ಓಕೆ. ಸೊ ಇಫ್ ಇಟ್ ಈಸ್ ಬಿಯಾಂಡ್ ದಟ್ ಶಾರ್ಟ್ ಆದಾಗ ಕರೆಂಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೋದ್ರೆ ಅದಕ್ಕಿಂತ ಹೆಚ್ಚು, ಓಕೆ, ಅಟ್ ದಟ್ ಟೈಮ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಇಟ್ ವಿಲ್ ಬರ್ನ್, ಬ್ರೇಕ್ ಆಗುತ್ತೆ ವೈರ್, ಬರ್ನ್ ಆಗಿ disconnect ಆಗುತ್ತೆ. And you see the other fuses here. Based on the current rating, thickness keeps on differing. This is another type where you can see winding ಇದೆ ಒಳಗಡೆ. Okay, higher current rating ಗೆ. So thin ಆಗ್ತಾ you can see the fuse will be the current rating. It will be, if it is lesser, thickness of the wire is also less. So that is how we just see the different types of fuses. Okay, this is the structure of a fuse. You can just see. So two terminals will be there, and in between it has been connected with an fuse filament anta ಹೇಳ್ತೀವಿ ಇದನ್ನ. Okay, so that filament will dissolve ಅಥವಾ ಕರಗೋಗುತ್ತದು ಹೀಟ್ಗೆ. So then circuit will break. So loudspeaker. This is a symbol for the loudspeaker. Okay. Everyone must have been seen loudspeaker, the symbol. So these are what actually, what does it represents? The rings, half rings. Electromagnetic waves. Okay. Electromagnetic waves. This is a microphone which converts sound waves to the electrical waves. This is a symbol for a microwave. So sometimes we represent this lamp as with a circle with a round with an into mark. Sometimes we represent it with a bulb. Real agi. Okay. This is what I just wanted to show you. Different types of resistors. It's theory, I know anyway, because basics ಹೇಳ್ಬೇಕಿತ್ತಿದಲ್ಲ. Once this is completed, tomorrow onwards, we'll give you the different types of resistors. We'll explain about the color code. We will ask you to measure it. Wattage rating, tolerance. Same 1K if I give 10 resistors. If you really measure it with an multimeter, you can see the different values. Even though the tolerance is about 10%, differs. What is that? How it differs? That is what you have to learn. When you are connecting in a circuit, 1K resistor when I use it, it may be 10% difference idre, tolerance idre, it may be 900 ohms to 1100 ohms. Different values. If I give 10 1K resistors, the values will differ. That is why they call it as a tolerance. When the manufacturer in one batch, once at a time, thousands of lakhs of resistors manufacture adre, each resistor will differ in value little bit. That is because very nanoparticle of material difference in that. That's all. Nanoparticle aste. So therefore, they always mention with some tolerance. This is very important, tolerance ಅನ್ನೋ factor. Because in a circuit, let me say, I just wanted 920 ohms exact agi. Because of this tolerance, if it goes for 1100 ohms, it's no use for me. Because certain circuits which are very critically used, there the resistance value should be exact. 1 or 2 ohms ಅಥವಾ 10 ohms tolerance okay. 10% ಅಂದಾಗ 1Kಗೆ it may be 900 ohms, it may be 1100 ohms. But that much of tolerance may not be required in a very critical circuits where I just want a very precision current to be flown. So there plays this wattage rating very, very, very important. ನಾಳೆ ಮೆಷರ್ ಮಾಡಿ ಎಲ್ಲ 10K ಕೊಟ್ಟರೆ ಅಥವಾ 1K ಕೊಟ್ಟರೆ 10 ಕೊಟ್ಟರೆ how the tolerance differs, what the tolerance plays there. Okay, so that you just going to learn. Color coding ಎಲ್ರಿಗೂ ಗೊತ್ತಿದೆಯಾ? How many of you know resistor color coding? 1 2 3 4 ಗೊತ್ತಿದೆ. So different people will follow different nomenclatures. So for that, what we call it as somebody will follow that black boy runs over anger, but Veena gets wild. B.V. Roy had a beautiful wife. What is that?
Great.
Oh, so like that you will use your own coding. So I'll explain that what is a color and what is that tolerance color, how to measure it. Tomorrow completely half an hour theory andre 2 hours practicals. Okay. Okay. The specifications of resistors. Resistor specification anta kodi. Get the sheet, specification sheet. So one can go for an fixed resistor, one can go for an wire wound resistor. Okay. Get the specification sheets. We'll discuss about that tomorrow. ನಿಮ್ಗೆ ಡೌಟ್ ಬರಬೇಕು, ಸ್ಪೆಸಿಫಿಕೇಶನ್ ಓದಬೇಕಾದ್ರೆ should get a doubt that what is the temperature, what is that value, tolerance ಅಂದ್ರೆ ಏನು, ಇವೆಲ್ಲ ನೋಡ್ಕೊಂಡು ಬನ್ನಿ ನೀವು. Tomorrow I'll explain about this. Okay.